The first three patterns in a sequence of patterns are shown below. Pattern 1, Pattern 2, Pattern 3. Draw the fourth pattern in the sequence. Part B, complete the table below. So fill in the empty boxes. Part C, show that the numbers of black triangles form a quadratic sequence. Part D, how many black triangles are in the ninth pattern? How many white triangles in the ninth pattern? How many small triangles in total are in the ninth pattern? Write an expression in n for the total number of triangles in the nth pattern. F. The number of black triangles in the nth pattern is given by the formula Bn equals a half n squared plus 3 over 2n plus c. Find the value of c. Part G. Use your answers to part E and F above to find a formula for the number of white triangles in the nth pattern. And H. One particular pattern has a total of 625 triangles. Find the number of black triangles and the number of white triangles in that pattern. So the first three patterns in a sequence of patterns are shown. Part A, draw the fourth pattern in the sequence. So in the first term we notice we have 2 black triangles at the base. In the second one we have 3 black triangles at the base. In the third one we have 4 black triangles at the base. So in the fourth term we're going to have 5 black triangles at the base. And then we're just going to build it up. So we have 5 black triangles on the bottom, then 4 black triangles, then 3 black triangles, then 2 black triangles, and then 1 black triangle at the top. So part B, complete the table. We need to fill in the number of black triangles, the number of white triangles, and then the total number of triangles. Okay, so in the first term, we have 1, 2, 3 black triangles, and that's already given to us, and 1 white triangle in the center. In the second term, we have 1, 2, 3, 4, 5, 6 black triangles, and we have 1, 2, 3 white triangles. In the third term, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 black triangles, and 1, 2, 3, 4, 5, 6 white triangles. So we start to notice a pattern. To get to 6, it was 3 plus 3. To get to 10, it was 6 plus 4. To get to 15, it was 10 plus 5. To get to 15, it was 15 plus 6. So we added on 3, then 4, then 5, then 6. So obviously if we wanted to get the 6th pattern, we'd add on 7. To get the 7th pattern, we'd add on 8, and so on. So the number of white triangles, to get from 1 to 3, we added on 2. To get from 3 to 6, we added on 3. To get from 6 to 10, we added on 4. To get from 10 to 15, we added on 5. So again, there's a pattern. We're adding on 2, then 3, then 4, then 5. Then for the total number of triangles, we just add them all up. 3 plus 1 makes 4. 6 plus 3 makes 9. 10 plus 6 makes 16. 15 plus 10 makes 25. 21 plus 15 makes 36. Part C, show that the numbers of black triangles form a quadratic sequence. So these are the number of black triangles, 3, 6, 10, 15 and 21. So if we write the numbers out crossways, we can get the difference between each term, and then we have to get the second difference to prove that it's quadratic. So we've got 3, 6, 10, 15, 21. To get from 3 to 6, we add 3. To get from 6 to 10, we add 4. To get from 10 to 15, we add 5. To get from 15 to 21, we add 6. This is known as the first difference. Since the first difference is not the same, we know that the sequence is not linear or arithmetic. So then we get the second difference. To get from 3 to 4, we add 1. To get from 4 to 5, we add 1. To get from 5 to 6, we add 1. Since the second difference is the same, we know that the sequence is quadratic. So the steps are check the first difference, and then check the second difference. Since it has the same number, it is quadratic. So since the second difference is constant, or is the same number, it is a quadratic sequence. Part D. How many black triangles in the ninth pattern? How many white triangles in the ninth pattern? How many small triangles in total in the ninth pattern? Okay, so we end up getting 55 black triangles in the ninth pattern, 45 white triangles in the ninth pattern, and 55 plus 45 gives us 100 small triangles in total in the ninth pattern. So let's have a look at where those numbers came from. Well, we had already filled in up as far as pattern 5. So if we have a look at where those numbers came from, we added on 3, then 4, then 5, then 6 to get each of those numbers. So we're going to then add on 7, 8, 9, and 10. So 21 plus 7 is 28. 28 plus 8 is 36. 36 plus 9 is 45. And 45 plus 10 is 55. So there are 55 black triangles in the ninth pattern. So then let's have a look at the white triangles. We had 1, 3, 6, 10, and 15. And to get those numbers, we added on 2, then 3, then 4, then 5. So next we're going to add on 6, then 7, then 8, then 9. So 15 plus 6 is 21. 21 plus 7 is 28. 28 plus 8 is 36. And 36 plus 9 is 45. So there are 45 white triangles in the ninth pattern. And then to get the total number of triangles, we just add each of these numbers together. So 28 plus 21 is 49. 36 plus 28 is 64. 45 plus 36 is 81. And 55 plus 45 is 100. Alternatively, you might have noticed that this is the square number sequence. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So the number of small triangles in total in the ninth pattern is 100. Part E, write an expression in n for the total number of triangles in the nth pattern. Okay, so the triangle sequence that we actually have for the total number of triangles starts at 4. So we've got 4, 9, 16, 25, 36, and 49. So this is our sequence. Now the square number sequence is 1, 4, 9, 16, 25, 36. Because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So our triangle sequence is the same as n squared, but it starts at 4, not 1. So our sequence starts at 4, but the square number sequence, or the n squared sequence, starts at 1. So it starts one step forward compared to n squared. So we can see that our sequence starts one step forward compared to n squared. So instead of starting at 1, our sequence starts at 4. So our nth term is going to be n plus 1 squared. If it had started 2 steps forward, so for example, if our sequence had actually started at 9, so if we got rid of the 4 and it actually started at 9, then it would be n plus 2 squared. If our sequence had actually started at 16, so that being 3 steps forward, it would be n plus 3 squared. F. The number of black triangles in the nth pattern is given by the formula Bn equals a half n squared plus 3 over 2n plus c. Find the value of c. So our formula is Bn equals a half n squared plus 3 over 2n plus c. So we're going to substitute 1 in place of the n, in place of each n in our formula. So we're going to have a half times 1 squared plus 3 over 2 times 1 plus c. 1 squared is 1, and a half times 1 is a half. 3 over 2 times 1 is 3 over 2 plus c. And we're going to let that equal to 3 because there are 3 black triangles in pattern 1. So term 1 is equal to 3. So a half plus 3 over 2 is 4 over 2 plus c is equal to 3. 4 over 2 gives us 2 plus c is equal to 3. We minus 2 to both sides, so c equals 3 minus 2, which is 1. So c is equal to 1. Use your answers to part E and part F above to find a formula for the number of white triangles in the nth pattern. Okay, so from part E, we got our formula to be n plus 1 squared. And from part F, we got our formula to be a half n squared plus 3 over 2n plus 1, because we got C to be 1. So this is our formula for the total number of triangles. And this is our formula for the black triangles. And if we want to figure out the number of white triangles, it's the total number of triangles minus the black triangles. And that will leave us with the number of white triangles. Likewise, let's say we were actually looking for the number of black triangles. It would be the total number of triangles minus the white triangles. So we've got the total number of triangles, which is n plus 1 squared, minus the black triangles, which is a half n squared, plus 3 over 2n plus 1. N plus 2 squared have worked out over here to give us n squared plus 2n plus 1. A minus by a half n squared is minus a half n squared. A minus by 3 over 2n is minus 3 over 2n. And minus by 1 is minus 1. The plus 1 and the minus 1 will cancel. And n squared minus a half n squared is a half n squared. And 2n minus 3 over 2n is a half n. So our formula for the number of white triangles is a half n squared plus a half n. H. One particular pattern has a total of 625 triangles. Find the number of black triangles and the number of white triangles in that pattern. So what we have to do is let the total triangles nth term equal 625. So our total triangles formula is n plus 1 squared, and we let that equal 625. And then we just have to solve for n. So we want to get the n on its own. So to get rid of that squared part, we're going to have to square root both sides, because the opposite of x squared is the square root of x. And that will cancel out the squared. The square root will cancel out the squared, leaving us with n plus 1. And the square root of 625 is 25. Then we minus 1 to both sides to get rid of that plus 1. And n is going to be equal to 24, because 25 minus 1 is 24. Now we have to substitute n equals 24 into the black nth term and the white nth term formulas. So our white nth term formula is a half n squared plus a half n, and our black nth term formula is a half n squared plus 3 over 2n plus 1. So we're subbing n equals 24 into both of these formulas. So we get a half times 24 squared plus a half times 24. And then we get a half times 24 squared plus 3 over 224 plus 1. So then we just work them out. So a half times 24 squared is 288. Half of 24 is 12. 288 plus 12 is 300. So we get 300 white triangles. And then a half times 24 squared is 288. 3 over 2 times 24 is 36. Bring down the plus 1. 288 plus 36 plus 1 is 325 black triangles. And to check are we right, we add them together and we get 625. So 300 plus 325 is 625. So we know we're right.